Narrate this in a dramatic, cinematic storytelling style, with tight pacing, slightly fast delivery, minimal pauses, smooth, continuous flow, and one consistent narrator voice from start to end. Africa's Secret Nuclear Story. The mystery hidden beneath 2 billion years. The secret nobody talks about. Imagine discovering evidence of a nuclear reactor. Not in America, not in Russia, not inside a military bunker, but deep beneath the soil of Africa. Now imagine learning that this reactor wasn't built by scientists. It wasn't built by engineers. It wasn't built by any civilization. Because according to everything we know, it existed nearly 2 billion years before human beings ever appeared on Earth. At first, that sounds impossible, the kind of story that belongs in science fiction. But in 1972, a discovery made in a French laboratory sent shockwaves through the scientific world and forced experts to investigate one of the strangest mysteries ever uncovered. A mystery buried beneath the forests of Gabon. A mystery involving uranium, missing radiation, ancient geological processes, and a place so extraordinary that some scientists described it as nature's own nuclear reactor. Yet even today, many people have never heard of it. And perhaps that's what makes this story so fascinating. Because hidden within Africa lies evidence of an event so unlikely that if it had not been documented by scientists themselves, few would believe it ever happened. Tonight, we travel into the heart of Africa to uncover the truth behind one of the most astonishing discoveries in modern science. And by the end of this story, you may realize that nature is capable of things far more mysterious than we ever imagined. Chapter 1. The Anomaly. The story begins in France, at a nuclear fuel processing facility. For the technicians working there, it seemed like an ordinary day. Shipments of uranium arrived regularly from around the world. Every batch was tested. Every sample was measured. Every detail was recorded. It was routine, predictable, almost boring. Until one shipment arrived from the African nation of Gabon. When scientists analyzed the uranium, something immediately stood out. The numbers were wrong. Not dramatically wrong, just enough to raise concern. The concentration of uranium-235 was slightly lower than expected. To most people, this sounds insignificant, but for nuclear scientists, it was a red flag. Natural uranium contains a predictable amount of uranium-235. The ratio remains remarkably consistent across Earth. Yet this sample was different. At first, researchers suspected an error. The instruments were checked. The calculations were repeated. Fresh samples were tested. Again and again. Every result pointed to the same conclusion. Some of the uranium-235 was missing. The question was simple. Where had it gone? The answer was anything but simple. Because the evidence suggested something had consumed the uranium. And the only known process capable of doing that was nuclear fission. A process normally associated with reactors, or bombs. Suddenly, a routine laboratory test had become an international scientific investigation, and nobody yet realized how strange the truth would be. Chapter 2. Following the Trail. Investigators trace the uranium back to its source, the Oklo mining region of Gabon, located near the equator in Central Africa. Today, Gabon is known for dense rainforests, rich biodiversity, and vast mineral resources. But beneath its surface lies one of the world's most important uranium deposits. When scientists arrived at Oklo, they began examining geological samples taken from deep underground. The deeper they looked, the stranger things became. Certain isotopes appeared in unusual concentrations. Specific nuclear byproducts were present. Patterns emerged that seemed impossible to explain through ordinary geology. The rocks appeared to contain evidence of sustained nuclear reactions. Not explosions, not contamination. Controlled reactions. The same kind of reactions produced inside modern nuclear reactors. For scientists, this was shocking. Yet another surprise was waiting. When researchers dated the rocks, they discovered the reactions were unimaginably old. Not thousands of years old, not millions. Nearly 2 billion years old. At that moment, the mystery became something much bigger. Because humanity had only learned to harness nuclear energy in the 20th century. How could evidence of nuclear activity exist billions of years before civilization? The question sounded absurd, but the evidence was undeniable. Something extraordinary had happened at Oklo, and scientists needed an explanation. Chapter 3. A reactor built by nature. As investigations continued, researchers began reconstructing conditions on Earth 2 billion years ago. The planet was different then. The atmosphere was different. The continents looked different. Even uranium itself behaved differently. One critical detail changed everything. 2 billion years ago, natural uranium contained a much higher percentage of uranium-235 than it does today. That meant ancient uranium deposits were naturally more reactive. Now imagine a rich uranium deposit buried underground. Groundwater slowly flows through it. The water slows neutrons. The reaction begins. Energy is released. Heat builds. The water eventually boils away. The reaction stops. The deposit cools. Water returns. The cycle starts again, over and over, thousands of times. A natural feedback system, a natural reactor. Nature had accidentally assembled all the ingredients needed for nuclear fission. No engineers, no technology, no civilization. Only geology, chemistry, and time. Scientists calculated that these natural reactors operated intermittently for hundreds of thousands of years, generating energy long before animals existed, long before forests, long before humanity. The discovery transformed scientific understanding forever. But it also sparked a different reaction outside the scientific community. Because not everyone accepted the explanation. And that is where the mystery truly began. Chapter 4. Theories in the Shadows. When the Oklo discovery became public, fascination spread quickly. The idea sounded almost unbelievable. A nuclear reactor older than humanity? For many people, the explanation felt too extraordinary to be true. Alternative theories emerged. Some suggested an unknown advanced civilization once existed on Earth. Others proposed visitors from another world. Books were written. Documentaries were produced. Speculation exploded. After all, humans naturally search for intelligent causes behind remarkable events. But scientists continued examining the evidence. Again and again, the data pointed toward the same conclusion. The reactions matched exactly what would be expected from natural nuclear fission. No signs of machinery, no artifacts, no hidden technology, no evidence of ancient engineers. The mystery wasn't that someone built the reactor. The mystery was that nobody did. Nature itself had accomplished something humanity once believed required intelligence. And perhaps that reality was even more astonishing. because it challenged a deeply rooted assumption. The assumption that complex systems always require complex designers. At Oklo, nature proved otherwise. Yet another mystery remained, and it would have enormous implications for the future of nuclear energy. Chapter 5. The Lesson Hidden Underground. As researchers studied Oklo more carefully, they noticed something remarkable. The radioactive waste produced by the ancient reactors had barely moved. After nearly 2 billion years, many radioactive elements remained close to their original locations. This finding attracted enormous attention, because modern societies face a difficult challenge. What should we do with nuclear waste? How can it be stored safely for thousands of years? At Oklo, nature had already performed an experiment lasting longer than human civilization itself. Scientists realized the site could provide valuable insights into long-term waste containment. In a sense, the ancient reactors became a natural laboratory, a glimpse into Earth's ability to isolate radioactive materials over vast periods of time. The implications were profound. A mysterious geological curiosity suddenly became one of the most important case studies in nuclear science. And yet, despite its significance, most people around the world had never heard of Oklo. One of humanity's greatest natural discoveries remained hidden in relative obscurity. Buried beneath forests, buried beneath history, buried beneath time itself. Chapter 6. Africa's Nuclear Legacy. The story of African nuclear history does not end with Oklo. In many ways, it begins there. Africa possesses some of the world's most significant uranium resources. Countries across the continent have played important roles in supplying materials used by nuclear industries worldwide. Yet discussions about nuclear history often focus on Europe, America, or Russia. Africa's contribution is frequently overlooked. The discovery at Oklo reminds us that Africa occupies a unique place in the nuclear story, not merely as a supplier of resources, but as the location of one of the most extraordinary scientific discoveries ever made. Long before reactors powered cities, long before nuclear submarines crossed oceans, long before atomic weapons reshaped global politics, the geological foundations of nuclear science were already hidden beneath African soil, waiting to be discovered, waiting for humanity to catch up. And perhaps that is one of the most fascinating aspects of this story. The knowledge was always there. The evidence was always there. Humanity simply hadn't noticed. Chapter 7. What Oklo Teaches Us. The deeper we examine this mystery, the more it changes our perspective. Most people imagine nature as simple, predictable, primitive compared to human technology. But Oklo tells a different story. Nature is not simple. Nature is capable of astonishing complexity. It can create crystals more precise than machines, ecosystems more interconnected than cities, and under the right conditions, even nuclear reactors. The discovery forces us to reconsider our place in the universe. Many technologies we celebrate as human achievements are actually attempts to imitate natural processes. Flight was inspired by birds. Engineering learned from biology. And nuclear science ultimately revealed something humbling. Nature reached the destination first, billions of years before we did. Final chapter. The Silent Reactor. Imagine standing in the forests of Gabon today. The air is warm, the trees sway gently in the wind. Birds move through the canopy. Everything feels ordinary, peaceful. Yet beneath your feet lies the remains of something extraordinary. A reactor that operated before animals existed, before dinosaurs walked the earth, before humanity dreamed its first dream. For hundreds of thousands of years, it quietly produced energy. No witnesses, no civilization, no history books, only silence. Then it stopped. The rocks cooled, the ages passed, mountains rose and eroded, species appeared and vanished, civilizations emerged, empires rose and fell. Humanity learned mathematics, built cities, crossed oceans, discovered electricity, unlocked the atom. And finally, after 2 billion years, we stumbled upon the evidence, as if nature had left a message waiting for us. Not a message written in words, but in stone. A reminder that the universe is older, stranger, and more creative than we often imagine. The mystery of Oklo is not a story about aliens. It is not a story about lost civilizations. It is not a story about secret technology. It is something far more profound. It is a story about humility. A story that reminds us how little we truly know. Because somewhere beneath the forests of Africa, hidden for billions of years, nature quietly accomplished what humanity once believed impossible. And perhaps the greatest mystery is not how the reactor formed. Perhaps the greatest mystery is how many other wonders still remain undiscovered, waiting beneath deserts, waiting beneath oceans, waiting beneath mountains, waiting for the next curious mind willing to ask a simple question. What if the impossible is already real? And what else is Earth still hiding from us? Fade to black.